The rest of section 10.7 is just more examples of the same thing. We're going to factor and set each factor equal to 0. That's what's important. To solve an equation, we set each factor equal to 0. And that's why it's so important that to begin with, we have equal 0, which in this case we do. Now we just use all our factoring strategies that we've been learning. The first factoring strategy is to check for a GCF. And I started writing the G. Let's write first check for a greatest common factor. Especially if there's an ax squared, if there's a number in front of the x squared, I would rather not use the AC method. So let's see if we can divide everything by 3. Oh, look, we can. So I'm going to divide by 3, divide by 3, divide by 3. Now that 3 is still part of my factoring. The greatest common factor is still there, but now it should be a lot easier. 3 divided by 3 is 1, and then 18 divided by 3 is 6. So now that there's no a there, we just use regular factoring where we need to multiply to the last number and add to the middle number. So I make a list of what multiplies to 6, or in this case, negative 6. But I'm just going to focus on the positive, and then we'll worry about what to do with the negative. So 6 is either 1 times 6 or 2 times 3. We need to add to positive 1. So it's looking like I need to make this 2 negative, and then the 3 positive, and then it would multiply to negative 6 and add to positive 1. To add to a positive, the bigger number has to be positive. So these are my factor pairs. So let's write it out here. We still have this GCF of 3, and then it's x minus 2 times x plus 3. After we took out the GCF, there wasn't an a here, so we don't have to do the splitting the middle with the AC method. Now this one's a little different because really there are 3 different factors. But this first factor, the 3, if I tried to set it equal to 0, it just wouldn't work. 3 doesn't equal 0. But if it were something like 3x, then we would need to set that equal to 0 and solve for x. But if there's no x in it, that can't be 0. Because remember, it's x that we're trying to get by itself. All right, but let's do the next 2. X minus 2 equals 0, or x plus 3 equals 0. So this, I'd always do the opposite to get x alone. The opposite of minus 2 is plus 2. The opposite of plus 3 is minus 3. So we didn't get a solution from the GCF, but we do get 2 answers, 2 and negative 3. Both of those, if we put them in the original equation, would make it true. All right, let's try the next one. Y squared minus 25 equals 0. This only has 2 terms, this polynomial. First, double check that it equals 0, check. But now that it just has 2 terms, we only have one way to do that, and that's difference of 2 squares. Oh, and look, it is squares. We have y being squared minus 5 being squared. So the way to factor this is y minus 5 times y plus 5. And still equals 0. If you need to check, do FOIL, right? Make sure you get y squared minus 25 again to make sure your factoring's right. But once we have that factoring, we set each factor equal to 0. So either y minus 5 equals 0 or y plus 5 equals 0. So that'd be y equals 5 or y equals negative 5. Those are our 2 solutions. I ran out of room on the previous one, so I didn't check, but we got room on this one, so let's check our answers. It's also, this one's a lot easier to check too. So it's y squared minus 25 equals 0. And these are the 2 y values we found. So the first one would be 5 squared minus 25. Does that equal 0? Yep. 25 minus 25 is 0. Negative 5 squared minus 25, does that equal 0? Yeah, because negative 5 squared, make sure you're putting a negative in parentheses, then it would equal 0. Yep. Okay, so that's what checking looks like. It's not necessarily difficult. It's a lot easier though when there's only 2 terms. All right, let's try this part C, because that looks different. First thing I gotta do is get the equal 0. And right now I definitely do not have that. So we're gonna need to multiply this 8, get rid of the parentheses, and then move everything over on the left side. So the x squared is 8x minus 16. I always try to keep the x squared positive. So I'm going to move the 8x and the 16 and leave the x squared on its side. So minus 8x plus 16 on both sides of this equals. So these will cancel. So we'll get equals 0. And then on the left side, I get x squared minus 8x plus 16. All right, we got our equal 0. Took a little bit of work, but that's not too bad. And now there's no a in front of the x squared, so this shouldn't be too difficult. We just need to multiply to 16 and add to negative 8. Well, what multiplies to 16? 1 and 16, 2 and 8. 4 and 4. Oh, this both need to be negative to multiply to a positive and add to a negative. And I think negative 4 and negative 4 will do it. So the factored version is x minus 4 times x minus 4 equals 0. And if I set each factor to 0, we get x equals 4 twice. So we're only going to put that in there once in our solution set, right? So the factors, we just get one answer, it's 4. Since there's one answer, that should be easy to check. I am going to check in the original equation though. So this would be 4 squared, and we want to know, does it equal 8 times 4 minus 2? So I took the original equation and replaced both x's with 4. On the left side, we get 16. On the right side, it's 8 times 2. That seems like it checks out.